Hey everybody, Mr. Bowman here. Another video on 2.6 Algebra. This video we're focusing on all the merit questions for the 2019 exam. Just a reminder, if you're wanting a heap other merit questions, check out the comment section or the bio for this video, and there will be a link for some more merit questions. So let's get into question number 24. That's the first one. So we've got a drug. It's used to reduce the level of cholesterol in the blood. So I'm assuming that's what C stands for here. So I'm assuming the terrestrial level, and I'm guessing it's meant to go downwards like a parabola does as well. For the daily dose, the unit T is in months, so that's probably noteworthy. The function is only valid for the first 15 months, so it's only valid for between 0 and 15. So what I'm thinking is, if we get a value for T that exceeds 15, like 25, 30, whatever it might be, we know that might be potentially a false answer. A person with an initial cholesterol of 9.18 is given the drug. How long would it take for the cholesterol to reduce to this? So I guess the first thing to do, before we can do this part of the question, we need to figure out K. So we need to figure out the complete function to then find out this 5.05 stuff. So let's start by jotting down my partial function. So the cholesterol will be equal to 0.02 t squared minus 0.6 t plus k. So I guess the good thing to know is this number here, this relates to the initial cholesterol level. So at that point there, initial tells us that time is going to be equal to 0. So 0 time has passed, and our cholesterol level at that point in time, C, was equal to 9.18. So what I'm going to do is I'm going to substitute both of these into this equation. That means K will be the only letter left, and I can go ahead and solve for K. So let's substitute them both in. So we're going to have 9.18 is going to be equal to 0.02. So t squared becomes 0 squared minus 0.6t, which is 0, plus k. So that and that is 0, which means k is equal to 9.18. So let's jot that down. K is equal to 9.18, which means my entire function, cholesterol levels, can be modeled by this function here. C is equal to 0.02 t squared minus 0.6 t plus 9.18. So I've now got the next part here. When will they have a cholesterol, or how long will it take to have a cholesterol reduced to 5.01? So this here tells us that C is equal to 5.01. And T is what we're trying to find out. So we're trying to solve for T. So let's take away the C over here and substitute in 5.01. So we've got 5.01. That's going to be equal to 0.02 T squared minus 0.6 T plus 9.18. Now this is just a quadratic equation, so what I'm going to do is I'm going to use the graphics calculator to do this for me, but to do that it needs to be equal to 0, so I need to move that positive 5.05 to the other side as negative 5.05. So basically that's going to become minus 5.05 on both sides. So that will cancel out, and we'll just have to figure out what that there comes to. So that means 0 is going to be equal to 0.02 t squared minus 0.6 t plus 3.13. Hopefully I've done my maths right there. No, 3.1. Yeah, no, 3.13. I like it. So now that I've done that, I'm going to put them into my graphics calculator. And from here, I know that A is going to be equal to 0.02. B is going to be equal to negative 0.6. And C will be equal to 3.13. Putting that into my calculator, don't forget it's a quadratic, so I'm going to get two different answers here. So when I did that, my first answer for T was 23.2, and my second answer for T was 6.8. Both of those there had a 1 dp rounding. So the issue here is, though, we've got two answers. That doesn't really make sense, and that's when my inequation here comes in. So T had to be between 0 and 15, which means T1 is not a valid answer. So that means T1, also T cannot equal to 23.2, as T must be between 0 and 15. So we can now communicate the final answer. Because it's a merit question, you're going to want to put it into a bit of context. So it will take 6.8 months for the person's cholesterol. Geez, hopefully I can spell cholesterol right the first time. Cholesterol to reduce to 5.05. Okay, we're now moving on to question number 25, and this one here gets fairly messy, but fairly okay once you get into it. So basically we've got a fraction here, and we've been asked to express it as a single fraction in its simplest form. So I guess the starting point for me was I noticed down the numerator, so down by the denominator, I had some quadratics. I could factorize both of those quadratics. So let's do that to start off with. So 2c plus 1 over, so this here is a difference between two squares, right? So that's going to be c minus 3, c plus 3. C minus 3, and then c plus 3. And then we're going to add on this here. Again, the denominator is going to be factorized. So c minus 2 on the top of that. And that's going to become, what's that? So that's going to be c minus 3. And then c minus 1. So both negative there. So I've got that there. Now this here's a bit of an issue. I can see they've both got the c minus 3 on the denominator, but the next part of the denominator is different. So basically what I'm looking to do here is my new denominator, I'll write it down the very bottom. I'm aiming to get my denominators both to be c minus 3, c plus 3, and then c minus 1. So that means I've got to multiply this fraction here. I need to get the c minus 1 involved for that fraction. So that fraction there needs to be multiplied by c minus 1 over c minus 1. And my second fraction, well, that's missing c plus 3. So that fraction there needs to be multiplied by c plus 3 over c plus 3. So let's put that into a single one. So don't forget the numerator times numerator needs to happen. And then the denominator times the denominator needs to happen because we're multiplying these fractions. So that's going to be, the numerator will become 2c plus 1, c minus 1. And that there will be over c minus 3, c plus 3, and then the new addition to the denominator, what we're aiming for, c minus 1. I now repeat for my second fraction. Again, it needs to be top times top, and then bottom times bottom. And we're going to put them all in brackets. Of course, separated by a plus sign there because we've got a plus sign in it. So it's going to be plus, and then the top's going to become c minus 2, c plus 3. All of that's going to be over that there, which is c minus 3, and then c minus 1, and our new addition to the denominator, c plus 3. And this is exactly what I'm aiming for because now my denominator, even though they're in a different order, it's got the exact same brackets everywhere. So I can merge these as a single fraction now. So it's going to be numerator plus numerator on the top over my common denominator. So it's going to be 2c plus 1, c minus 1. And then we're going to add on c minus 2, and then we've got c plus 3. All of that there is over c minus 3, c plus 3, and then we've got c minus 1. So I've got it as a single fraction. That's a big tick. However, it's not really simplified at this stage because we've got two messy brackets. At a minimum, all of this can be simplified together to c squared c number form. But optimistically, if we do that, we might be able to factorize and cancel out something from the denominator. So let's start expanding that stuff on the top. So we're going to have that times that, 2c squared, that times that, minus 2c, and then along there, plus c, and then down there, minus 1. Repeat the same, that times that, c squared, that times that, plus 3c, that times that, minus 2c, and then that times that, minus 6. And all of that is over my denominator, which is unchanged, c minus 3, c plus 3, and then c minus 1. Okay, so I now need to simplify all of this mess. It's going to get a bit tricky, or we just got to manage everything properly. So c squareds go first, so that plus that, we're going to have 3c squared, right? So we've got 3c squared. Now, the numbers here are a bit tricky. So this here comes to minus c, this here comes to positive c, and the minus c and the positive c cancel each other out. So there's no c's here. We've now just got the number to deal with, the numbers. So we've got minus 1, minus 6, that comes to minus 7. So we're going to go minus 7, and all of that is going to be over c minus 3, c plus 3, and then c minus 1. Oh, I've got c squared, isn't it there? So that's empty c squared. So there's no way to factorize this, so there's no way I can cancel out a common factor here. So that there's my simplest answer. So a bit messy to get there, but hopefully it helps out. And do be careful, go slow, and pay attention when you're doing questions like this. Okay, we're now on to question number 26. And this one here is a bit tricky, I think, first go. If you haven't seen one like this, it's going to be pretty tough. But we've been asked to fully factorize this. So when I think about this as, you know when you expand quadratics, you've got something to do with x squared, x, and then a number at the end. You end up with 4 parts. If there's a coefficient, you use something called the grouping method to do that. You'll factorize the first 2, then you'll factorize the second pair. So I'm thinking best bet is probably going to be something to do with the grouping method. So what I'm looking to do here is I'm looking to kind of put together the things that I think are going to be in common. So if you compare the first 2 parts here, we've got fm, 6gn. So they've got nothing in common. But this has an m and this has an m. So what I'm going to do is I'm going to rewrite it as so f times m minus 2gm. I'm then going to put the other parts together. They're the ends, aren't they? Oh gosh, I've deleted that one there by accident. Bit of a nightmare there. So we're then going to have, let's put the positive one first. So we're going to have plus 3fn minus 6gn. So hopefully you can see there, I've got the m's over here and the n's over here. I'm now going to factorize both of those groups. So this group here, the only thing they've got in common is the m. So that there is going to become m bracket, what was that, f minus 2g. Over here, they've got a 3 in common. They've also got an n in common. So I'm going to take out that 3n. So I'm going to go plus 3n bracket f minus 2g. And I'm loving the line of working I've got now because do you see how the bracket is the same? That means my hunch is right. It is something to do with the grouping method. So what I can do is I'm going to basically take out the common bracket. So f minus 2g, and my leftovers, m plus 3n, they're going to form the second bracket. And I'll show you what I mean by that. So we've got m plus 3n, close bracket. Okay, and our very last question for the 2019 exam, question number 27, or the low battery pen's getting up there, so we better get a move on. So we've got basically a virus is increasing exponentially at a constant rate of that, and we can kind of see that number appearing in the formula there. N is the initial number of people diagnosed with the virus, and N would be the current number after however many time has passed. How long will it take for it to be 3 times the initial diagnosed? So the way I started that one was if, let's say the number of people, I'm just making up these numbers, let's say 1 person was initially diagnosed, that means N must be 3 because we're waiting for it to be 3 times. So I'm going to substitute both of these into this expression here, and I'm going to solve it. And you could have picked any numbers, so let's say you picked 1,000 up here. If you picked 3,000 here, it's going to get to the same outcome. Because, this would have been divided by this, which is 3. This would have been divided by this, which is 3. So either way, you're going to get the same answer. So let's jot down my formula. So n is going to be equal to the initial n times by 1.053 to the power of t. And don't forget, we're solving for t here because we're trying to figure out how long. So n, as I said, is going to be equal to 3. N, 0 is 1, so that we can just ignore that. And then that will be 1.053 to the power of t. I've got an unknown power, so I love seeing unknown powers because that's my clue. I think I'm going to log both sides and try to use a log rule to figure it out. So log 3 is going to be equal to log, I wrote log 1.053 to the power of t. So I'm going to apply one of the log rules. I'm going to move the power here, put it out front as multiplication, and that way I can isolate that variable a bit more easy. So we've got log 3 is going to be equal to log, t will be out front, wouldn't it? So t comes there, t times log 1.053, and now this log thing here, that's just a number. I'm going to move it to the other side, so that multiplication is going to become division. So that's going to be log 3 divided by log 1.053, and that there is equal to t. And when I plug that into my calculator, T is going to be equal to 21.3 weeks. And I chose to round that to 1 decimal point. So that wraps up all the merit questions from this video. Just a reminder, if you're wanting more merit questions like this from past NCQA papers, check out the link that I put into the description of this video. It's just got all of them in one place.